Hello everyone, welcome back to the Network Fixer. Today we are doing something special. This is a full deep dive masterclass on modern firewall architecture and deep packet inspection. This session will take you from core fundamentals all the way to enterprise architecture, vendor ecosystems, real world deployment strategies, and future trends in network security. If you are a network engineer, security professional, student, or tech enthusiast, this session will give you a strong conceptual and practical understanding of how modern firewalls work and why they are still the backbone of cybersecurity. Let's begin with basics. So you might be wondering why firewalls still matter in modern networks. The answer is pretty simple. Even in a world of cloud computing, zero trust architecture, and endpoint protection, firewalls remain the central enforcement point of network security. Every second, networks are exposed to scanning attempts, brute force attacks, malware delivery, and sophisticated intrusion techniques. A firewall acts as a policy enforcement engine that controls what traffic is allowed, inspected, or denied. But modern attacks are not simple port scans anymore. Attackers hide inside encrypted traffic, they use legitimate applications and exploit application layer vulnerabilities. This evolution forced firewalls to transform from simple packet filters into intelligent, application-aware security platforms. Let's walk through how firewall technology evolved. The first generation was stateless packet filtering. These firewalls inspected IP addresses and port numbers. They were fast but lacked intelligence. The second generation introduced stateful inspection. Firewalls began tracking sessions and understanding connection states. The third generation introduced application layer gateways and proxy firewalls, enabling deeper inspection. Today we use next generation firewalls or NGFWs. These integrate deep packet inspection, intrusion prevention systems, application awareness, SSL inspection, threat intelligence integration, behavioral analytics. Modern firewalls are security platform, not just filtering devices. Modern firewall architecture is divided into several planes. First is the control plane, which handles routing decisions, policy management, and system intelligence. Second is the data plane, responsible for real-time packet processing. This plane must operate at extremely high speeds with minimal latency. Third is the management plane, where administrators configure policies and monitor performance. Enterprise firewalls also use dedicated security processors, hardware acceleration chips, and parallel processing architectures to achieve high throughput. Modern firewalls rely heavily on specialized hardware. They use multi-core CPUs, network processors, ASIC acceleration, FPGA-based inspection engines. Hardware acceleration allows firewalls to inspect traffic deeply without becoming performance bottlenecks. This is especially important for encrypted traffic inspection, which requires heavy computation. Now let's talk about key industry players. Cisco manufactures high-performance firewalls through their Secure Firewall and Firepower product lines. Palo Alto Networks is known for advanced next-generation firewall platforms and application visibility. Fortinet produces FortiGate firewalls with custom security processors for high throughput. Checkpoint focuses on enterprise-grade security gateways and also unified threat management. Juniper Networks, which is currently owned by Hewlett Packard Enterprise, integrates firewall capabilities into its SRX series. Other important vendors include Sophos, WatchGuard, SonicWall, Huawei, Barracuda, ForcePoint. Each vendor offers different strengths in scalability, performance, and security features. Firewalls are no longer limited to physical appliances. Virtual firewalls run inside hypervisors and also cloud platforms. Cloud-native firewalls protect workloads in AWS, Azure, and Google Cloud. These firewalls scale dynamically and also integrate with cloud orchestration systems. They support hybrid environments where on-premises and cloud networks operate together. Now let's move on to the art of today's session, deep packet inspection or DPI. Traditional inspection looks only at packet headers. DPI analyzes the entire packet payload. This allows firewall to detect malware signatures, identify applications, enforce content policies, recognize attack patterns. Deep packet inspection provides context and intelligence beyond simple filtering. When a packet enters the firewall, several stages occur. The first one being the firewall performs packet normalization and reassembly. The second one is with that it identifies the protocol and application using pattern recognition. Next, it compares payload data against threat signatures and behavioral models. The next step is that the firewall enforces policy decisions. All of this happens within microseconds. Modern firewalls use advanced techniques to identify applications regardless of port numbers. They rely on signature matching, behavioral heuristics, machine learning classification. This allows organizations to create granular policy based on application behavior rather than just ports. When it comes to encrypted traffic, the firewalls do inspection, which is one of the most demanding tasks in the firewalls. Modern firewalls act as trusted intermediaries that decrypt traffic, inspect it, and re-encrypt it. This process requires certificate management and careful privacy considerations. Without SSL inspection, many threats remain invisible. IPS or intrusion prevention systems are integrated into modern firewalls. IPS engine detects exploit attempts using signature databases, behavioral anomaly detection, protocol analysis. When combined with DPI, IPS provides real-time protection. Segmentation also limits attack spread. Firewalls enforce boundaries between network zones. Microsegmentation applies security policies at granular level even within data centers. This approach reduces lateral movement by attackers. Firewall performance depends on hardware acceleration, efficient rule ordering, traffic shaping, load balancing. Poorly optimized firewall creates bottlenecks. Proper tuning ensures both speed and security. Modern firewalls generate rich telemetry. Logs provide insights into traffic behavior. Security analytics platforms correlate firewall logs with threat intelligence. Also, the visibility enables proactive defense. Firewalls can be deployed in several models: perimeter security gateways, internal segmentation firewalls, data center firewalls, cloud edge security. High availability clustering ensures redundancy, and load balancing distributes traffic across multiple units. So when it comes to the firewall policies and best practices, effective firewall policies follow the principle of least privilege. Only required traffic is allowed. Policies should be reviewed regularly. Automation tools help maintain consistency. When it comes to the integration with the security ecosystems, modern firewalls integrate with SIEM or SIM platforms, endpoint detection systems, threat intelligence feeds, security orchestration tools. This creates a unified defense ecosystem. Firewalls now use sandboxing to analyze suspicious files. Machine learning detects unknown threats. Behavioral analytics identify anomalies. These features extend protection beyond signature-based detections. So if you ask me about the future trends, the future of firewalls include artificial intelligence-driven threat detection, cloud-native distributed firewalls, integration with zero-trust architectures, SASE or Secure Access Service Edge models, quantum-resistant encryption research, automation and self-healing security systems. Firewalls are evolving into intelligent, adaptive platforms. Let's consider a case study scenario. Imagine an enterprise targeted by ransomware. The firewall detects abnormal encrypted traffic. DPI identifies malicious behavior. IPS blocks the connection. Threat intelligence confirms the source. The attack is neutralized before spreading. This illustrates the practical power of modern firewalls. When it comes to challenges and limitations, firewalls face challenges like any other devices. There are complexities of encrypted traffic. Sometimes there are chances of performance overhead. There is a possibility of privacy concerns. Sometimes configuration errors can cause a huge impact for the end users. Security teams must balance protection and usability. If we consider the best practices, keep systems updated at all the times, enable logging and analytics, implement segmentation, use layered security, train personnel continuously. Security is a process, not a product. Modern firewall architecture and deep packet inspection are essential for defending today's networks. Firewalls have evolved into intelligent security platforms capable of adapting to advanced threats. Understanding their architecture, capabilities, and future direction is critical for anyone working in networking and cybersecurity. Thank you for spending this time with the Network Fixer. If you found the masterclass valuable, subscribe for more detailed technical sessions on networking and security. Just in case if you are new to my channel, please do subscribe to my channel, hit the bell icon and like the video. I will see you in the next video. Until then, take care of yourself, stay curious and keep learning. Thank you for watching. You have a great day. Bye bye.